you want to become Iron Man, you got to start somewhere. And it was really fascinating having the opportunity to interview Arron Acosta with Rise Robotics, because they're starting at the perfect place, which is essentially the muscles of the robotics, which currently everything is big and bulky and it requires a lot of power, and they're working to solve that problem. I also really liked a lot of the insight that he had about education and the reason why he went into it. Basically focus on a project that you want to see happen, something that you want to see exist in the world, and then go after it, as opposed to finding some degree without any sense of direction. And when I think of the future of exoskeletons and what this can be applied to, this isn't just the world of industry and lifting heavy boxes on the job or things like that, which that's great. It'll help you, avoid back problems if you've got assistants to do it. It'll help, in the medical field, lifting up patients or emergency situations. But this is also great because it could just be really fun. This could be recreational. You could run faster and jump higher. And I hope you enjoy the interview. If you want to get more information about Rise Robotics, just visit their website. It's riserobotics.com. I'm standing here with Arron Acosta, CEO of Rise Robotics, and he's here because he wants to become Iron Man, basically.
Yeah, that's right. We want to be superhuman, and in order to do that, we realized the importance of actuation. So we invented the breakthrough necessary to make that possible.
Now, what makes this more advantageous to current actuation technology?
Power density.
Okay.
It's lighter and stronger.
And what applications do you see this applying to in the future?
Well, exoskeletons can be used for industrial productivity, like at a shipyard where you're holding a 20-pound tool. Currently, you might use a tool balancer that's on the ground, and then you have to adjust it and move it around. But you could have a wearable tool balancer, whether you're on a machine line at a car factory, or at Boeing building a plane, or at Hyundai building a boat. If your tools were supported by your hips, like a backpack was, instead of by your wrists and your elbows and your shoulders and your back, and we'd have less injuries on the job site. So workman's comp would be lower, industrial productivity would be higher, and the user has a more enjoyable experience. That's one.
And what kind of capabilities do you see this really improving that we couldn't do before?
Right, so right now exoskeletons have found a niche in the medical rehabilitation space because the person using the exoskeleton has no power to begin with. So if you think of it like a car with horsepower per pound, if you've got 0 horsepower, any additional amount of horsepower is sincerely appreciated. And going from nothing to something is a big deal for somebody whose current life is wheelchair bound, or they're using sticks with handles. So for that type of application, you could charge a lot of money because there's a lot of pain, and the technical challenge is easy, and that makes it a really nice starting spot for exoskeletons. But in order for exoskeletons to be everywhere, in order for you and me to be wearing exoskeletons on the way to work instead of in a car or a motorcycle, or after work playing, jumping around and running and lifting heavy things, having like a superhuman Olympics, if you will. For that to happen, we need low cost, and we need much more powerful and lightweight components. So in pursuit of our ultimate goal of an exoskeleton, we realized that it was really about the components themselves. So we took a detour and we invented the components necessary. And that's what we're displaying today, and we'll soon be showing the products that use these components.
How much weight have you got on the device right now?
So we're using a weed whacker from Home Depot that was $97 that we disassembled.
Okay.
It's a 40-volt battery, and it's pulling about 10 amps. We're able to lift 50 pounds through 8 inches in less than a second.
Wow.
And you could do the power calculation for power in, power out, but it's so efficient that when we let off of the motor, after we've picked up the weight, the energy that was in the battery is now stored in the potential of the weight at a distance off the ground, right? So energy, potential energy is mgh, mass times gravity times the height, and as we let go of the power controller, the weight does this funny thing where it actually pulls on the piston and it sends the power back into the battery.
Okay.
So it's a generator.
Oh, so you get it back
Yeah.
on the return.
It's so efficient that we can send it in and we can get it back. And it's called backdriving. And there's some other companies here that I highly encourage you to check out, like harmonic drives.
Okay.
And this is their bread and butter. And if you also want to realize what the problem is in this industry right now, go ask the really amazing robot arm companies how much their gears cost.
Okay.
That's the question.
Now, if somebody wanted to get into this particular field, what degrees or education would you recommend somebody pursue?
As many projects with Arduino and Raspberry Pi and 3D printers. I think courses are irrelevant. As a CEO hiring people, I cut straight to the chase. I want to know, what did you do in your free time just because not doing it would have irritated you? You know, what did you do because you were obsessed and you had to, because you were fascinated and you needed to, because you were in that moment of creation where you lost 12 hours and it was 5 in the morning and you like had to hit print, and then you went to bed and you woke up and then you saw it and it sucked, so you did it again and again and again. That's what I want to know about. So I'm more interested in, like, do you have a 3D printer and do you use it? Do you have an Arduino and do you program it? Do you have nuts and bolts, and like, what have you done? You know, what have you made? Like, I don't care what you've studied.
Creating value.
Because the whole point of studying a class, and what I've also noticed is that I retain more in my classes that I'm studying if I have a project that I'm trying to put it into. You know, it's mind at hand. It's about putting knowledge into something. So for a recommendation, I would say take as few classes as you can and do as many projects as you can that need those classes in order for the project to be successful.
Okay.
So before you pick classes at the beginning of your semester, trimester, quarters, or whatever, first ask yourself, what do I want to do project-wise? And if you have nothing, go copy somebody. Go find something that you admire and copy it. And then in the pursuit of copying it, then figure out what classes do I need to take that will enhance and augment my project.
Yeah, Neil Gaiman was talking about that whenever he's saying make good art, to copy somebody else to begin with until you find your own voice.
Totally. I mean, how else are you gonna know? Like, you have to be familiar with your materials and your methods. So I think another thing that I would do, and we do, is you have a benchmark of all your favorite materials and how they perform. You should know the yield strength of steel and aluminum and polyurethane. And you like, if you're a mechanical guy, if you're a software guy, you should know about different libraries and different. You should know about recursion. You know, you should use recursion. You should solve the noise tower. You should go to the next level and, you know, like, go down the rabbit hole until you find rock bottom. You can't go any further, and then go get a professor and a grad student and a bunch of your peers in a class that's pushing your boundary. So that's what I do.
Well, thank you very much. This is Value Time TV, and signing off.